Thanks. I'm Hiroaki Yutani. Today I will talk about GeoJSON and GeoArrow. I'm a software engineer at Mierune Inc. Mierune is a GIS company in the northern part of Japan. I occasionally contribute to various OSs, including DuckDB, and my current focus is Sedona DB. If you use the R language, you might know me as one of the ggplot2 maintainers. Okay, let me start with this question. Do you like GeoJSON? No. Yeah, mixed. We have mixed feeling about GeoJSON. The good part of GeoJSON is it's a text format, and the bad part of the GeoJSON is also a text format. I mean, talking about GeoJSON is almost like talking about the advantages and disadvantages of the text format. GeoJSON, good thing about the text format is that many tools support it. JSON is especially portable. Because web browsers can parse JSON, we can use GeoJSON easily on the web browsers. And it's also human readable. I find it sometimes useful, but the bad thing is GeoJSON is bad in terms of efficiency. We have parsing overhead, we have writing overhead. I mean, since it's a text format, we have to convert it to text. Since it's a text format, it needs to be parsed when we want to load it into some system, or it needs to be written back to text when we want to pass it to another system. Its file size is also a headache. Let's think about a typical web application. We have database, and we have app server, and we have web browser. If we use GeoJSON, we hit such overhead several times. So first, while the database stores the data as binary, it needs to convert the data into GeoJSON text format. If you are using PostGIS or DuckDB, this is typically done by SD as GeoJSON. And next, the app server receives the GeoJSON. And the server needs to parse the text into binary again, into some JavaScript object or something. If this is Node.js server, this is done by JSON parse or something. The same kind of conversion happens between the web server and the web browsers. So even in this simple example, we had many round-trip conversions from binary to a text, the text to a binary, the binary to a text, and the text to a binary. Yeah, as you can imagine, this can be worse if the system is more complicated. Yes. Of course, this is not always a problem. This is fine as long as the data is small, but overhead does matter on larger data. Can we get rid of such overhead? Yes. We can use GeoArrow. Sorry, I'm not good at AI, so all figures are hand-generated. GeoArrow can travel from end to end without any unnecessary conversions. So what is GeoArrow? GeoArrow is a specification for storing geospatial data in Apache Arrow. What is Apache Arrow, or simply Arrow? Arrow is a columnar memory format for general purpose. This is not only for geospatial data, but also for various data. It is designed for zero-copy reads, which means it's ready to be used without any conversion. In comparison, GeoJSON is not zero-copy because it needs to be converted from text to binary. This conversion process means there are two copies, the original text and the newly parsed binary data. So there's a copy, not zero copy. Yeah, and Arrow aims for cross-language interoperability. It provides libraries and tools for many programming languages so that allow data can universally read and written. The idea is very simple. We have many tools and programming languages. They use different data representation in memory. So we have to convert the data from one format to another if we want to pass the data between them. By using Arrow, we need no conversion because many tools and languages can read and write Apache Arrow. In reality, we still need some conversion or copies, but it's much better with Apache Arrow. So what's the relationship between GeoArrow and Arrow? Arrow defines the actual memory layouts, and GeoArrow defines what the geometry is represented as using Arrow. So Arrow is a very low-level thing, but the GeoArrow specification is simple if you are familiar with GeoJSON or some other data format about geospatial. So let's look at the specification a bit. A coordinate is represented in either of the two forms, separated or interleaved. It might not be very obvious how different they are. In the separated representation, the data consists of 2 to 4 arrays for X, Y, Z, and M each. On the other hand, the interleaved representation uses one single array. As this is a bit too low level a thing, I won't go into the details. In short, the specification says the separated form is recommended for most use cases, but interleaved form is still useful for some use cases. For example, passing data to GPU buffers directly. Okay. Now that we covered the coordinate definition, the rest is simple. A point is a coordinate, and a line string is an array of coordinates. A polygon is an array of arrays of coordinates, and so on. Okay, let's move on. Thanks to GeoArrow, we can move data from end to end without overhead. But this is not all. If we use the data carefully, the GeoArrow data can reach your GPU. But bad news. I apologize, but recent FOSS4G workshop was so good that I had to rethink this part. But let's not talk about it for now. Yeah, this workshop, you can blame this workshop. Okay, and so you might wonder why GPU matters here. This is because modern MapLibre libraries relies on GPU to render maps, like Deck.gl, MapLibre, and Cesium. Yes, typically this is done by a WebGL or a web GPU. Longboard is a great example of how powerful GeoArrow is. Longboard is a Python library to visualize geospatial data. It uses GeoArrow to pass data from Python to JavaScript and then to the GPU via Deck.gl. This is possible because Deck.gl has a low-level interface that accepts binary data directly. So thanks to these technologies, Longboard handles GIS data very efficiently. You can smoothly visualize very large data that other tools cannot handle well. So perfect. In Python, you have many data sources that can transfer data in Arrow memory format. For example, PostGIS and DuckDB. You can also use GeoPandas to read various formats of geospatial data. Then you can pass the data to Deck.gl. Perfect, if you are using Python. But what if you are not using Python, especially if it's a web application? Fortunately, there's a JavaScript library to render GeoArrow data on Deck.gl. This is Deck.gl layers. This provides GeoArrow version of Deck.gl layers. The API is almost the same as the original one. So this is very easy to use if you are familiar with Deck.gl. Have you ever used DuckDB WASM? DuckDB WASM and this library are a perfect combo. DuckDB WASM can read remote geoparquet files or other various geospatial formats and output GeoArrow. So this is awesome if you want to do everything on web browsers. Yeah, but what if you want to offload those processing to backend servers? Or what if the output is not Deck.gl? So we have challenges on the web. I think there are two categories of challenges. The first one is about DB connectivity. And the second one is about the map rendering library itself. Let's talk about the first one. In order to connect the database, we need either a database connector or a SQL gateway. Database connectors. If you are familiar with databases, you probably have heard of JDBC and ODBC. But how about ADBC? ADBC stands for Arrow Database Connector. ADBC is really cool. It transfers data in Arrow memory format. So this is a perfect fit for our use case. It supports many languages, C, C++, Go, Python, R, Rust. You can choose your favorite one. And it provides many drivers, DuckDB, Postgres, SQLite, BigQuery. And also, it's easy to manage these drivers using DBC CLI, which is released very recently. Yeah. So this is like this. However, the problem is ADBC is not available for JavaScript or TypeScript. So yeah, that's a problem. To be fair, we can use other languages to implement servers, but I think it's not very handy. Yeah, so that's a problem. And next, SQL gateways. By SQL gateways, I mean services that provide HTTP API for executing queries. For example, PostgREST is a service that exposes a REST API for a Postgres database. There are a few other SQL gateways. However, as far as I know, the output is either JSON or CSV. No one outputs Arrow except for Arrow API. Yeah, but anyway, it seems SQL gateways are not designed for large data. Okay, next topic. Map rendering libraries. There are many map rendering JavaScript libraries. Does any of these support GeoArrow? What do you think? We already know about the status of Deck.gl. There is a great npm package to support GeoArrow. So in other words, GeoArrow is not supported natively, at least at the moment. So how about others? In order to investigate, I simply searched the word GeoArrow on GitHub repositories. Can you guess how many issues were hit? Yeah, 0. No single issue mentioned GeoArrow. So why? Is it technically impossible? I don't think so. It might be difficult, but I believe it's possible. Here's my proof of concept to draw GeoArrow polygon on MapLibre GeoJS. I mean, without Deck.gl, I load a custom shader. This is a very simple example, drawing only one polygon with a bit of fancy interaction. Maybe I have time to show this a bit. Yeah. This effect is meaningless just to show I wrote a shader. Yeah. Okay. So this is not, I think this is possible. And I've been thinking about this for months while preparing this presentation, but I haven't found an answer so far. Maybe it's just GeoArrow is not so popular enough. If so, I hope my talk today contributed to spread the word a bit. Okay, this is summary, but sorry. I plan to conclude my presentation here, but unfortunately, I got a few words to say. So let's return to this slide. I said GeoArrow can reach your GPU, but it's not very accurate because GPU cannot render polygons directly. I mean, what polygon can render is triangles. So what we have to split the polygon into many triangles before passing to GPU. This process is called tessellation. Have you ever heard of tessellation? Tessellation is horrifying, as evidenced by the fact that its most famous algorithm is named. I think this is my best slide. EACAD. Do you know this algorithm? Looks horrifying. Yeah. sorry, I'm kidding. It's not horrifying. But I just wanted to say tessellation can be horrifying costful. It takes computation resources. And to be clear, not all geometries require tessellation. For example, you can pass points directly, and I'm not sure lines. Okay, and so there's remaining question about GeoArrow. GeoArrow itself doesn't take care of tessellation, so it needs to be tessellated before passing to GPU anyway. Then where should tessellation happen? On backend servers, on web browsers, or somewhere else? I think this is an open but important question. Then here comes the MLT, which I learned from the workshop. MLT stands for MapLibre tiles. This is next generation vector tiles format, which supersedes MVT. MLT can contain pre-tessellated polygons. Yeah, I think this is very cool. So if we can generate MLT on the fly, this might be better than GeoArrow if we use polygons a lot. Yeah, so here's my updated summary. GeoJSON is cool, and there are many tools that supports GeoJSON. GeoArrow. Sorry, GeoArrow is cool, and there are a lot of tools that support GeoArrow. Yet on the web, the support is very limited. And but some pre-tessellated format might be better than GeoArrow in some cases. Yeah, that's all. Thank you.
Let's see if we can get this one on too. We only have one mic. Be nice to have a second mic for questions. Do we have any questions for you, Tani? Thank you very much for that talk. Very enjoyable. Well, this helps it get captured in the recording. So I'll do the game show host sort of thing here.
Thank you. Thank you for your presentation. Naive question here. How's GeoArrow related to GeoParquet? And it's the same issue here with GeoParquet as with GeoArrow?
You mean same issue our web browsers? I think, I mean, GeoArrow and GeoParquet is a different thing. GeoArrow is for data exchange, and GeoParquet is for storing the data on disk format. So this is a bit different, but I think GeoParquet is, we can use, for example, DuckDB wasm to query GeoParquet files, or there are some other libraries. I think GeoParquet is well supported on web browsers as well. Does this answer your question?
It tells me what to look for more. Yes, thank you.
Oh, thank you.
Any other questions?
Yeah, I already have the mic. Thanks for the talk. It's just a couple of points, not a question on Deck.gl. So we are planning on adding GeoArrow in-memory support. It's not something that's easy to do because it's quite low level, but it is on the roadmap. And on the triangles, I would just say that we do have a binary format, and you can pass the triangles in directly. But if they're not there, then they get filled in. And it's one of these trade-offs that you have between how big is your data payload and how much processing does the client have to do. So I think on this, it's not like one true answer that one is better. Like you might end up bloating how much data you're sending with the triangles and save a bit of processing time. But if you're then sending all these triangles, which can be a lot of data, then you're sending them all the way from the database through all your other servers, and they're only actually needed for the rendering. But thanks for the talk. It was nice, and some very funny slides, so I appreciate that. Especially Earcut, that's genius.
Yes, thank you. I agree that it very much depends on the data. So yeah, I want to explore this topic more. Yeah, thank you.
Yeah, great talk. I also loved the visualizations there. Yeah, one other note on the tessellation. There's a helper library now called GeoArrow.js, and so that has some utilities for doing some GeoArrow-based stuff on the web. And so that.
I actually used that on my demo.
Okay, yeah.
Yeah, so
So there's a utility there that calls earcut, or that calls earcut on a GeoArrow polygon array. And so Lawnboard actually moves that onto a web worker. So it uses up to 8 web workers for doing that triangulation. And so that's something you could look at if you want existing work of arrow-based tessellation. Yeah. But it uses earcut, and I love the earcut diagram.
Thank you.
I have one question for you, talking about the GeoJSON versus GeoArrows option. Is one of the things I've always disliked about GeoJSON is that everything's in WGS 84. When you use a GeoArrow, can you use different projections on it?
I think GeoArrow itself doesn't contain any CLS, so you can use any projection, but it needs to be managed in the different layer, or so how can I say? Yeah, so it's transparent from the projection, I think. Does this answer your question?
We still have time for one last question if there is one. Here we go.
Hey, thank you. Great talk. I'm just wondering, in your move from GeoJSON now to GeoArrow, is there anything that you miss about GeoJSON, or is GeoArrow just better for everything?
Sorry, could you ask me again?
Are there any drawbacks to GeoArrow versus GeoJSON?
Drawbacks. So yeah, I mean, there's less support on GeoArrow, and since it's a binary format, we cannot read it directly like GeoJSON. It's not human readable. So I think that's a drawback.
That's all we have time for tonight. Can we hear one more round of applause for Yutani? Thank you very much.